So tangent of x, before you do any funny business with it, tangent of x, something like this. Goes through the origin, and it has a period of pi, which means it repeats itself every pi units in the x-axis. And at pi, negative pi over 2 and pi over 2, that's where your vertical asymptotes are. And that's because tangent is sine over cosine, right? Well, cosine is 0 at pi over 2. Cosine is 0 at negative pi over 2, so that results in that divide by 0 problem that gives you a vertical asymptote. So that's regular tangent of x. To graph this crazy transformation, the first thing you'll want to do is put it in a standard form so we can make some interpretations. Okay, we'll want to factor out the 1/4. You want to have this factored so that you don't have a coefficient of x after you've factored. So I'm factoring out that 1/4. And if I factor out a 1/4 here, 24 divided by 4 makes 6, right? So that's pi over 6. Okay, so now it's like in a standard form for a trigonometric function. Now we can more easily identify the horizontal shift. The horizontal shift is just, it's minus pi over 6, so it's kind of in reverse. That means we go pi over 6 units to the right. This is where it originally crossed the x-axis. Now we have a horizontal shift of pi over 6 units to the right. Now it's going to cross at pi over 6. It should look something like this. Crossing there. Okay. The other thing to look out for is this 1/4. We call that the b, the coefficient of x. It's called b. And when you calculate the period, if you remember from sine and cosine, when we graph those functions, the period is just pi over b with tangent or cotangent. Okay. Not 2 pi over b, but pi over b. So this is our b. So you got pi divided by 1/4. So you'd flip and multiply to make that 4 pi. That means tangent of x should start repeating itself after 4 pi units. So I've done my horizontal shift. I've got to keep that in mind because the vertical asymptotes aren't negative 2 pi and positive 2 pi. I've got to take my take where I cross the x-axis, because that's usually the center of the graph, and I'm going to take pi over 6 and subtract 4 pi. Sorry, it's not 4 pi. I need to subtract 2 pi from it. That way I have 2 pi to the left and 2 pi to the right. So to subtract pi over 6 by 2 pi, I'm going to get common denominators. This is 6 over 12. So what does that give us? Negative 11 pi over 6. That's the left vertical asymptote. Our graph should have negative 11 pi over 6. And then same thing for the right vertical asymptote. I want to take pi over 6, but this time I want to add 2 pi units to it. And so that's 12 over 6 plus 1 over 6. So that's 13 pi over 6 here. And then we want to check our work. We want to make sure that we're completing a full cycle after 4 pi, because that's what we found the period to be. So 11 pi over 6 plus 13 pi over 6 makes 24 pi over 6. So that's 4 pi. So there's our vertical asymptotes. Dealt with those numbers. Oh, shoot, I forgot about the minus 3. That's a vertical shift. Instead of having this graph that I've drawn, we just need to draw the same graph 3 units down. So negative 11 pi over 6 to 13 pi over 6 still for our vertical asymptotes. Pi over 6 is still that center, but now it's been shifted 3 units down. So that's a rough sketch of what our graph should look like. And then the last part, I tried to pull it up so I could do this in Newton, because I know in Newton there's a blue dot that you have to adjust. Okay, well, since you have freedom to move that blue dot, I'm pretty sure you can move it where you want, up and down. You want to make sure you move it to a point that actually exists in this equation. In other words, you want to move it to a point so that you can plug in the x and the y coordinates, and it turns out to be true. Or another way is you could graph this in desmos.com/calculator and then click and drag on the graph to find out some actual point values and where the blue dot could go. But I'm not sure what they would do. One thing they usually do is like y equals 1 is a dot, but that one is y equals 1 is going to be up here. I don't think they would do that for this one. let me pull it up. I don't know what they would do for the blue dot because this is a rough sketch of our graph, but it could be more like this. You know what I mean? Or it could be more flat near the point here, like this. So that's the part that Newton's trying to get you to graph. So in Newton, for the correct answer, they're looking for a blue dot right here. And so to find out what the corresponding x value is when y equals -2, you can plug in -2 into this equation. -2 equals tangent 1 over 4x minus pi over 24 minus 3. And then solve that equation for tangent. Usually the blue dot they have is such that if you plug it in the y coordinate, and then solve for tangent, just get the trig function by itself like I'm doing right here. It seems to be equal to 1. I don't know if that's just something they do with their software or not. But again, with this last part, once you get the vertical asymptotes, once you've shifted it down 3 units, pull up desmos.com/calculator and make sure your blue dot that you choose is actually a point on that graph when you type this function in desmos.com. So there's an angle that makes a tangent ratio equal 0. We want to know what this angle should equal, so that tangent equals 1. And in the unit circle, that only happens at 45-degree angles. Okay, because if you have a 45-degree angle and you made a right angle with the x-axis, like we usually do for our trig angles, then you have pi over 2 and pi over 2. No, wait, sorry, I don't know what I was thinking. Square root of 2 over 2. And square root of 2 over 2. So in other words, sine divided by cosine makes 1. For tangent to equal 1, this has to be a 45-degree angle. In other words, a pi over 4 angle. So you're solving this mini equation. So you solve that equation for x, and then you'll have your ratio that you need. So you want to add 24 to both sides, pi over 24 to both sides. So what is that? That's 6 pi over 24 plus, so that's 7 pi over 24. So we got 1/4 x equals 7 pi over 24. So to finish getting x by itself, I'd multiply 4 to both sides. So I get x is 7 pi over 6, right? Let's check. I think I got the correct answer here too. Yeah, y equals -2, 7 pi over 6. It's a little bit bigger than 1 pi, so that's where the blue dot goes. Okay, why did we pick -2? I think it's because Newton only lets you move that blue dot straight up and down. You've got to just find the y coordinate that could actually exist on this graph. If you were to bring it here and plug in -1, if you plug in -1 in for your y value and try to solve, it's not going to be something possible that you can graph. And if you pick 0 and plug that in for y, like a y coordinate of 0, then you try to solve that, it's not going to be something that lands on this graph. So that's where going to desmos.com/calculator is going to be good. Okay, you can plug in what the graph is supposed to look like, 1/4, and then you can use that to help you guide you with that last point. Okay, so that part's kind of tough because it's really fighting with the software to get the right graph. But